Here's the scenario. You have a fabric F32 capacity with a warehouse called DW1 using MD5 hash surrogate keys. The fact table has grown from 200 million to 500 million rows over the past year. You have Power BI reports running on direct lake mode. Users are reporting degraded performance, and some visuals are throwing errors. You need to fix this with the best query performance while minimizing operational costs. Options: A. Change the hash to SHA256. B. Increase the capacity. C. Enable V-order. D. Modify the surrogate keys to a different data type. E. Create views. Before we touch the answers, you must understand direct lake guardrails. This is the trap. Every fabric capacity SKU has specific limits on how many rows per table direct lake can handle. And here's the critical number. F32 supports a maximum of 300 million rows per table. Our fact table has 500 million rows. It blew past the guardrail. When a table exceeds the guardrail, one of two things happens. If direct lake fallback is set to automatic, queries silently fall back to direct query mode, which is significantly slower. If fallback is disabled, the report simply fails to load and visuals show errors. That matches our scenario perfectly. Some reports are slow, some visuals are broken. So the real question is, how do we get 500 million rows working properly with direct lake? The F32 cap is 300 million. The next tier up, F64, supports 1.5 billion rows. That's more than enough headroom. Let's eliminate the others. Option A. Change MD5 to SHA256. This changes the hashing algorithm, but both produce string-based keys. SHA256 is actually longer, 64 characters versus 32. This doesn't reduce the row count, doesn't change the guardrail, and would actually make things worse. Gone. Option C. Enable V-order. V-order applies special compression and sorting to Parquet files for faster reads. It's a great optimization for Delta tables, and yes, it improves direct lake performance. But here's the thing. V-order doesn't reduce the number of rows. You still have 500 million rows. You're still over the 300 million guardrail. V-order can't bypass a capacity limit. It makes things faster within the guardrail. It doesn't fix a guardrail violation. Option D. Modify surrogate keys to a different data type. Switching from MD5 string hashes to integer keys would reduce column size and improve join performance. That's good practice in general. But again, you still have 500 million rows. The guardrail is about row count, not column size. The row limit doesn't change because your keys are smaller. You're still over 300 million. Option E. Create views. Views are logical layers. They don't reduce data, don't affect storage, and actually, direct lake doesn't even support views. If a semantic model references a view, it falls back to direct query automatically. This makes things worse, not better. The correct answer is B. Increase the capacity. By upgrading from F32 to F64, you jump from a 300 million row guardrail to 1.5 billion rows. Your 500 million row fact table fits comfortably within that limit. Direct lake mode works again. No more fallback to direct query. No more visual errors. Now, I hear you thinking, but the question says minimize operational costs. Isn't upgrading the SKU expensive? Yes, it costs more than F32, but here's the key. It's the only option that actually solves the problem. All the other options either don't address the row count guardrail or make things worse. When the question says minimize operational costs, it means among the solutions that work, pick the cheapest one. And since only one solution works, B wins by default. Here's your exam rule. Memorize this table. F2 through F32, 300 million rows. F64, 1.5 billion. F128, 3 billion. F256, 6 billion. When you see a question about direct lake performance degradation plus visual errors, immediately check the row count against the SKU guardrail. If it's over the limit, the answer is almost always increase the capacity. Like and subscribe, and I'll see you on the next one.